Hello class, welcome back to class. Today we're going to learn how to find the equivalent of fractions and the fundamental law of fractions. So let's get started by first reminding yourselves what are fractions. I'm going to read you a definition of fractions. So fractions is a part of a whole number and a way to split up a number into equal parts. So I'm going to show you guys an example. So these are fractions. So as we can see, the pi is a whole number. And we know that it has 1, 2, 3, 4, 5, 6, 7, 8 slices. So as we remind ourselves, that would be our denominator. And we know that there is 3 slices that are shaded. So that would be our numerator, 3. So the fraction would be 3/8. Okay, so now that we reminded ourselves what are fractions, let's start on how to find equivalent fractions. Equivalent fractions is fractions that express the same quantity. It's just trying to say that equivalent fractions are fractions with different numbers representing the same whole number. Right now, it might not make sense, but as we keep going, it's gonna make more sense. And we're gonna work with some examples to show you guys how it works. We're gonna start with example A. It's 2/3 and B 6/9, and we're gonna try to find the equivalent fraction. To find the equivalence of 2/3, we're just gonna add dashed lines going through each of the squares. Now that we've added the dashed lines, we can see that there is a new fraction. So we're gonna count each little square, and there's gonna be 1, 2, 3, 4, 5, 6. So the denominator would be 6. Now that we know that the denominator is 6, we're gonna count the shaded parts. So there's going to be 1, 2, 3, 4. So there's 4 shaded parts. So that's going to be the numerator. So that's going to be the equivalent fraction of 2/3 is going to equal 4/6. Now that we've learned equivalent fractions, we're going to learn the fundamental law of fractions. Fundamental law of fractions states that the value of fraction doesn't change when the numerator and denominator are both multiplied or divided by the same common factor. We're going to start with some examples. A, 2/3, and B, 6/9. So I went ahead and started working on the problem. I wrote 10/15 right here, and I found the common factor of both the numerator and denominator, which is 5. So I divided both top and bottom by 5, and 10 divided by 5 would equal 2. And 15 divided by 5 would equal 3. And if we multiplied 2/3 by 5, it would give us back to 10/15. So that makes equivalent fraction. So now let's start working on problem B, 35/63. And we're trying to find the equivalent fraction. So I wrote down 35 divided by 63. I found the common factor of both the top and bottom, which is 7. So I divided the top and bottom by 7. So I did 35 divided by 7 equals 5, and 63 divided by 7 equals 9. So the equation is going to be 5/9. So if I multiplied 5/9 by 7 to top and bottom, it would equal 35 or 63, which would give us the same equation. Okay, so now that we learned the equivalent of fractions and the fundamental law of fractions, I'm going to teach you guys an easier way to find equivalent fractions when given two fractions. And that's a theorem called the cross-product property of equivalent fractions. The cross-product property of equivalent fractions states that the fractions a/b and c/d are equivalent if and only a times d equals b/c. So we're going to work with some examples, and I'm going to show you guys how that works. Example A states is that we have to find the equivalent fraction of 3/12 and 2/8. And okay, so I'm going to show you guys. I went ahead like I always do. So I set up 3/12 equals 2/8. As the theorem states, we have to multiply across each other. So we're going to multiply 3 times 8 equals 24. And if we multiply 2/12, it equals 24. So the equation is equivalent. So this is true. Okay, guys, now that I taught you guys equivalent fractions and the fundamental law of fractions and how they work, I'm going to hand out some paperwork, and we're going to work together to solve the problems.